All right, so look at all this mess that we have here to get our three solutions, and we're going to take a look at B, which is right underneath this letter A in the textbook, and we're going to start with our rational roots theorem. So the first thing we're going to do is identify our P and Q. Here's our P. Now, technically, this constant is a -3, but we don't really look at the negative because all the values are going to be plus or minus anyway. So the good news about this P is there's less options. The only factors of 3 are 1 times 3. So plus or minus 1 and plus or minus 3. So that's awesome because that doesn't give us so many options to worry about. Then what we're going to do is come back over to our lead coefficient. That's the one that's in front of the x cubed, and that's a 2. And that's our Q value. And all of the terms or factors of 2 are plus or minus 2, right? 1 times 2 is 2. So this is where we need to do P divided by Q as a ratio for us to find all of our possible roots for our polynomial. So when we do P divided by Q, for this one, we're going to take each of these and put it over 1, and then we're going to take each of these and put it over 2. So we're going to have a couple different combinations here. So 1 over 1 is just 1. Actually, I guess I should do it this way to show you literally what this will look like when you do it. Okay, so we have plus or minus 1, plus or minus 3, over plus or minus 1, or plus or minus 2. So when we split these up, I'm going to do the plus or minus 1 over 1, which is just plus or minus 1. Plus or minus 3 over 1 is just plus or minus 3. Because 1 divided by 1 is 1, and 3 divided by 1 is 3. So that's our first two sets. Then we have to take plus or minus 1 from the P column and put it over 2. Well, 1 over 2 is 1/2, and you're going to write it as a fraction. And then we're going to do the same thing, plus or minus 3 over 2 as a fraction. Okay, so these are all of our possible real roots that could potentially work in our polynomial. So I'm going to start substituting them in just like I did here with all these blue. I'm going to do the same thing here. I'm going to use this polynomial, and I'll be back to show you your answers. And we're back, and here they all are filled in. Well, actually, I didn't even need to do plus or minus 3 over 2. And the reason why I know I didn't have to do that is because this is a degree of 3. That means the most real roots that it can have is 3 solutions. And as I was plugging them in, I found all 3 before I got there. That means why bother? They're not going to work because there's only 3 available at most. So I found it. We did our rational roots theorem. We plugged in the values. We found the ones that have a 0 remainder. That means it's a solution. So these are the 3 roots, or the 3 places where it crosses the x-axis. Okay, there's no bounces in this one because there are a total of 3 as the exponent and 3 as roots. So they just pass through when we're sketching.